days to sleep, and you didn't get any sleep?
No, I didn't. No, because I stayed up when I had a cold.
Yeah, but you could have slept in, right?
Yeah.
No? Did your mom wake you up like
Every
at 6 o'clock
morning.
every morning or something?
4 o'clock.
No? All right, get out your homework.
I still have
All right, any questions on the homework? Number, let's take a look at number 6 and 8. 6 and 8. All right, so we get this complicated picture, and I'm just going to warn you, tomorrow on the test, there will be another one of these complicated pictures. The key on these complicated pictures is taking your pencil, or maybe a colored pencil if you want to, and finding, look at me, finding the vertical lines. The vertical lines are formed with an X. As you look at it, you're like, yeah, I can see lots of X's, and that's the issue. Generally, when they're trying to mess with you, they are trying to mess with you, is that one of those lines isn't a line, it's a ray. Can you see? Can you see the one that's a ray? Which one is a ray? On top of page 63. Because all of these are applying to that one picture. Yes, exactly. And it will be on the test. Which one is just a ray, not a line? No, which one on the picture is just a ray, not a line? DG, remember you have to have 2 letters. So DG, that's a ray. The rest of them are either segments or line. So segments or line can make vertical angles. Rays, unless you have 2 rays that intersect, then you can't make vertical lines. Vertical angles, I'd say vertical lines. Vertical angles. So I know for me, whenever I put this on a test, obviously I'm the teacher, it seems easy to me, and I know it's confusing. I'm just going to warn you. I will put this, it'll probably look exactly like this, just flipped around and rotated. So take your pencil, and whenever you're asked to find the vertical lines, lightly shade the X that they're trying to get you to form or to make. All right, Danny, which one did you have problem on? Let's look at number 6. It says the measure of ADF. ADF. So that goes A to D to F. All right, that's a combination of ADC and CDF. Plus FDB. FDB equals 180. So what's definition or postulate says that 2 angles added together equals 180? There's 2 possible answers here, by the way. So it's basically saying that those two angles put together makes 180 degrees. There's 2 possible answers to that. The first one is the easier one, the one that says that, well, this angle plus this angle equals a bigger angle. Which one is that? And I'll just say this, anytime that you see anything where 2 angles are added together, in the entire book, there's only 3, 1 postulate and 2 definitions. And it's the angle addition postulate. The angle addition postulate says, take one angle, add it to another angle, as long as they're adjacent to each other, it equals the larger angle. The second 2 would be complementary, supplementary. So if you wanted to say supplementary angles, right? Definition of supplementary angles, you could. If you want, I guess there's a third possibility, the definition of a straight line, right? A straight angle, sorry. Straight angle has 180 degrees, so there's 3 possible answers just to number 6. The book says angle addition postulate, but the other 2 are fine. All right, Danny, that was number 6. You good on that?
Yeah.
What's the next one? Look at number 8. So it says 4 is congruent to 3. So that means Are you looking at the picture? Are 4 and 3 next to each other, opposite to each other, vertical to each other, what? Are angles 4 and 3, are they opposite each other? Are they no relation to each other? Are they next to each other? What? They're right next to each other. We have a word for that. The two angles are next to each other. They share a common vertex and a common ray. We call them. I'm next to each other. Mike, come stop. When two angles are next to each other, we say that they are. Okay, this is why that book of truth will save your butt on a test, because you can flip through it and see, well, what they're adjacent to each other. So we have two adjacent angles, 3 and 4. We okay so far? Further, it says that they're congruent to each other. So therefore, DG bisects them. Therefore, where do we get that they bisect each other in our book of truth? Do we have anything that talks about bisecting an angle in our book of truth? Well, let's see. Is it in a theorem? Nope. 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 I mean, there's not a single theorem that talks about so far bisecting an angle. Therefore, if it's not a theorem and it's not a postulate, what must it be? Just the definition of a bisector. That's it. Just the definition of a bisector. Definition of a bisector is a ray that cuts an angle in half, or it sets two angles equal to each other. So that one's a definition of a bisector. All right, that was number 9. Okay, yes, no? Yeah. I can tell you're kind of struggling with these, right? So what I want you to make sure that you do today and then tomorrow on the test is that book of knowledge. You can flip through it and you know what's in your book of knowledge. Our book of knowledge is really light. It should be, I don't know, how many pages? Maybe 4, right? Is it 6? Right? It shouldn't be that many pages to flip through. If you have all your definitions, postulates, and theorems in there, it's not much to flip through. All right, any other questions? All right, let's go over this. So it's 1 through 15 all. Now, if you have an answer that doesn't match mine, hey, tell me, and maybe it works. Some of these have multiple answers. The first one, there's only one. What is it? Yeah, I got 2 segments added to each other. It equals the longer segment. That's segment addition postulate. You put postulate 2, that's fine. I'm not going to ever remember it's postulate 2, so I would just put segment addition postulate. All right, number 2 is its twin. Therefore, the answer, Chandler, is? Okay, you got it written down? You got your homework from Thursday? You got your homework from Wednesday? Make sure that gets turned in. All right, number 2 is your angle addition postulate. Angle, it's the twin, right? This angle plus this angle equals the larger angle. Number 3 is the easiest one. That is? I'm never going to remember the number, so I'm going to write vertical angles are congruent, right? If you remember, it's 3 what? 2, 3. 2, 3, right, 2, 3. I'm not going to remember that. Neither will you in a month from now. But you will remember that vertical angles are congruent. All right, number 4 is the midpoint theorem. Remember, that's the theorem that literally says that one piece is half of the larger piece. A definition of midpoint would work as well, too. Absolutely, positively. But I will say this is the one that literally reads exactly like the theorem. But I would say definition of midpoint as well, too. Number 5, definition of bisector. And we've talked about 6. There's a bunch of answers for 6. 7. What do we have that if something's perpendicular that the angle is equal to 90? Definition of perpendicular lines. Even though they're talking about segments, right? Just remember it applies to rays, segments, lines, planes as well too. Number 8 is the definition of a bisector. Number 9 is definition of complementary angles. We actually only have one theorem about complementary angles so far. We'll have more, but right now we only have one, and that's dealing with if 2 angles are adjacent and they are perpendicular to each other. That's the only theorem that we have. But I would also accept, not for this one, but one I'm talking about, but I would also always accept definition of complementary angles or perpendicular lines.
Yeah, that's number 10.
All right, number 10. They are supplements, then this one plus this one equals 180. Well, what tells you if they're supplements that they add up to 180? It says that ADF, look at ADF, and then it doesn't say 2, right? You're expecting it to say 2. It says 4.
Yeah.
Well, how do you know that 2 and 4 are the same? Are they the same? You do vertical, well, the vertical to, yeah, there's the array right there. I agree. This one is a little bit weird. Give me a chance when we do the review. I'll take a look at that one. I don't have a good answer to that one right now. Well, okay. Oh, never mind. It's making the statement that they're supplements. So that's the if part. So if they say if, right, then, you know, it starts off with the word if. Yeah, so if they say the word if, then you accept that as gospel. Doesn't say they are, but if they are supplements, then the first one plus the second one equals 1. Yeah, that's fine. All right, number 11. If two lines are perpendicular, they form congruent angles. Why do they form congruent angles if they're perpendicular? Why? If two lines are perpendicular, it says the angles are congruent to each other. Why? If two lines are perpendicular to each other, I don't know if it's just lines or rays. If two lines are perpendicular, why is this angle congruent to this angle? Or this angle congruent to this one? Or this one congruent to that one? Why? Well, that would be true for this one and this one, but not this one and this one.
Because that one's all right.
Why are they congruent to each other?
They all equal 90 degrees.
Say again?
They all equal 90 degrees.
Why? What? You still haven't told me why. You just said because they're perpendicular, but why?
Because they are. It's the definition of a perpendicular.
What's the definition of a perpendicular line?
So we're playing this game. Right angles.
Well, it makes one right angle. Why does all of them turn into right angles? You still haven't.
Right angle. Perpendicular.
Take your magic hand. Oh, yeah. Flip back to page number.
This might not be the right way
Flip.
to do it.
Flip back to page 2, 1, 2, 3 back and read theorem 2.4. What's 2.4 say? Granted, I'm being a jerk right now by saying you are right, all of you, but you still haven't told me why that they're congruent.
Two lines are perpendicular.
Two lines are perpendicular. They do what? They form 4 congruent angles. Why? Because that's what theorem 2.4. And by the way, we proved it in class. I would have also, I think that would have been a better answer to my jerk question, which was, well, why are they congruent? Because they're perpendicular. Yeah, that truly is a statement that is true, but it doesn't answer geometrically the why part. Why? Because it's theorem 2.4 says it's true, and we proved theorem 2.4. All right, what number was that? 11. All right, number 12.
So is the definition of perpendicular lines correct?
I will accept that. I would rather say 2.4 is the better answer, right? But, okay, so by the definition of perpendicular lines, there are lines that are formed when two lines come together and it forms a 90-degree angle. And because of that, we get theorem 2.4, which says if two lines are perpendicular, then all the angles are congruent. All right, number 12. This is the one that you will forget, right? We get 2 of these. We get one for complementary, we get one for supplementary. If 2 angles are congruent to the same angle, right, and those 2 angles are congruent, and the original 2 were either complementary or supplementary to each other, then the original ones are congruent. And that is theorem, let's see, complementary is theorem, I get these backwards. One is complementary, one is supplementary. It is not substitution. It is theorem 2.7 is for supplements and theorem 2.8 is for complements. You will not remember that. You will remember that they are congruent to each other, but you won't remember which is which. So this is probably one of the few times where I literally would say, you know, theorem 2.7, because it's too long to write if 2 angles are supplements to two congruent angles or the same angle, then they are congruent to each other. That's a lot of words to write. Number 12 is actually the 2/8 because it says it has complementary and supplementary. All right, 13. If this angle is a right angle, why are they perpendicular? Is that what 2,4 says? No. If this is a right angle, then the two lines are perpendicular. Which one says that? 2,5 says if two lines form congruent adjacent angles. We could get there from there. You'd have to tell me that those two form a line, therefore they're supplementary to each other 90. An easier way of saying it is just definition of perpendicular lines. The definition of perpendicular line says what? They intersect. They form right angles where they intersect each other. Chandler, are you with us? All right, doesn't look that way. We're on 14. So I got two angles that are congruent. They're adjacent to each other. Looking at the picture, you would only get that from the picture. So I got two angles that are adjacent and they're congruent. What does that mean? And they form a line. Therefore, they are. We're given that. We have two angles that are next. So this is angle 1 and angle 2. So it says that 1 is congruent to 2, and they're next to each other, and they form a line. Therefore, what can you conclude? They're next to each other. That means adjacent. They're congruent to each other. Notice here's two angles that are next to each other. They're congruent. They do not form a line. But here's two angles that are next to each other. They are congruent. Therefore, what can you tell me? Not supplementary. Sure. So therefore, if the two angles are next to each other and they're supplementary and they're congruent, what's the only conclusion? They form a straight angle. Well, got that. What do you got, Jalen?
They're 90 degrees.
They're 90 degrees. They have to be. Are these 90?
No.
No, they're next to each other. I said they were congruent, right? They're clearly, but they don't form 180 degrees. But if two angles are adjacent, they share a vertex and a common ray. If they're next to each other and they're congruent and they form a line, they must be perpendicular. Not the we don't say the angles are perpendicular, but the lines are perpendicular.
So what's the answer? Definition of complementary angles.
Yeah, two lines form congruent adjacent. This is theorem. Two lines form congruent. This is theorem 2.5. This is theorem 2.5. All right, and then lastly, the proof. This was actually proving 2.7, the only one that we did not prove. And it's done exactly the same way that I did my proof in class, which is the first one is your given. The second one is definition of supplementary angles, two angles that form a straight line, therefore their sums are equal to 180. Then they do a substitution. Notice they did a reflexive property. I'm an anti-reflexive property person. Once you show that the two angles are the same, I don't need to say 5 is equal to 5, right? The measurement angle 5 is equal to measurement 5. But it's in their proof. Therefore, they subtracted 5 from both sides. And those are your answers. Given, definition of supplementary angles, substitution, and the subtraction property of equality. That is it. All right. This class scares me. Scares me. Right? We got a test tomorrow. Test tomorrow. So our first test was easy, right? Even though you may have thought it was hard. This test is more challenging, right? And then chapter 3 test establishes the baseline for what it'll be for the rest of the year. Like, it don't get any harder than chapter 3 test. It's just new material each time. Oh, by the way, geometry, unlike algebra, you're like, oh, I kind of remember doing this last year. You're not going to know any of this, ever, right? Every single day is a new day, new stuff, except for review day, which is today. So So this class scares me because I don't see like with exception of maybe 2 or 3 people in here, most of you kind of just sit there and kind of watch me go through the motions. So if that's your method of learning and it's effective and you're like, well, I get this all, then we're in a good position. I just don't think that's what's going on. I think that some of you just kind of like sitting there. And you're like, well, he's going to talk and eventually he'll stop talking and I'll go to another class, right? I mean, if that's truly what's going on, then you're not going to pass geometry. You got to interact. This is how you will learn it if you're interacting. So purpose of this speech is I'm going to show you what's going to be on the test right now. The issue with geometry is unlike algebra. In algebra, I can literally show you what's on the test. Hey, the first question is going to be solve a system of inequalities. Oh yeah, I can do those. That doesn't happen in geometry because there's every question is unique. So I can talk in general terms about what will be on the test, but I can't tell you any specifics. So if you've had me, some of you had me for 2 years, right? If you had me before, on pre-algebra and algebra 1, I literally hand you a copy of the test and say, here's the test. I go home and study it, come back and do it again. I just change the numbers around slightly and you get A's and B's. Geometry doesn't work that way. So the reason why this class scares me is 2 reasons. 1, all the tests are unique, right? You can't really do that much prep for it. And then 2, like the interaction we have been having as a class has been, I don't know, in my mind, it's been weak. Maybe with Matt is the only one that I would say is being a good geometry student. Sometimes Seth, sometimes Micah, a few others as well too. But if you are sitting there not getting this, right? Summer school is horrible. You don't want to go to summer school for geometry. You got to have geometry to pass high school. So doesn't matter what high school you go to, this one or any one. You got to have a high school credit for geometry. So let's try to focus. I will try to guide you through what's on the test, but it is just a guide. I can't get into the great specifics like I typically do in Algebra 1 or pre-algebra. Or next year, if you have me for Algebra 2, you're going to love Algebra 2. Most kids are like, oh, finally, we're back to the math that's easy. Geometry is not easy. All right, so we have a test tomorrow. Let's see what's on it. I'm not sure that you necessarily need to take notes about this, but some of you might, right? I'm not going to show you examples of anything. I'm just going to talk about what could possibly be on the test in general terms. So in general terms, I think there's like 17 or 20 questions on the test. I forget what. It's one of the 2. So I said this, and I've made this statement before. I said that you can get a C in my class if you can do geometry skills. So the first thing I will talk about are the skills that you need in order to pass this test. These are the skills. I'm going to break this down into a couple categories. The first one I'll call are the logic skills. So you tell me, and be truthful to yourself, you tell me whether you're ready for the test or not. So the first skill that you must be able to do on this test is this. I'm going to give you a conditional. You're going to tell me what the hypothesis is and the conclusion. Just like remember did on the quiz, right? I'm going to give you a statement. It will be an if-then statement. You got to tell me the hypothesis and conclusion. Easy or hard? As long as I write if and then, right? What if I don't write if and then? Okay, then it's partially easy. Who's confused on what that statement means? You got to be able to write the hypothesis and the conclusion of a conditional statement. If it rains, the road is wet. The hypothesis is, and the conclusion is, you tell me, can you do that? And then I made the statement which was, if I don't put the words if and then, Mom will give me $1 when I clean my room. What's the hypothesis? Okay. And notice there is even the word if in there, and now they're reversed. The if went to the conclusion, but the conditional is, right, I got to clean my room first. I got to clean my room first, then Mom gives me $1. Be careful with those. Well, $1 doesn't go as far as it used to. Okay. So we good? We understand? I will have one question on that. Just one, because it's really pretty simple, right? The second part is, can you write the converse of a given conditional statement? I'll give you the statement. If it rains, the roads are wet, and ask you to write the converse. What's the converse of that? Right, you tell me. You got this or not? All right. You need to be able to prove something is false. This is hard. I can't show you examples because any example I show you is specific to that one situation. If the roads are wet, then it's raining. Prove that wrong. Okay, there's a counterexample to that converse statement. So I'm not going to ask you to prove the converse is false. I'm just going to ask you to prove that something is false by giving me one counterexample. Most likely it will be a mathematical statement, and it will probably be a geometry statement. Okay? If two angles form adjacent congruent angles, then the lines are perpendicular. Prove it wrong. If two angles form congruent adjacent angles, then the two lines are perpendicular. If two angles are adjacent and they're congruent, then the line is perpendicular to each other. Right? So what would be a counterexample? This angle could be how big? You got to come up with one counterexample. 35. And this one could also be 35, and they make 180 degrees. There's your counterexample. Remember, that's the converse to the statement that if two adjacent angles are congruent, right, and they form a line, then the two lines are perpendicular. I mean, the original conditional is true. Two angles are adjacent to each other, they're congruent, and they form a straight line, then they're perpendicular, but the other one is not true. If two angles are adjacent and congruent, they don't necessarily have to be perpendicular. All right. We okay? Yeah, not much detail on that one. I will give you a statement. This is the Danny questions here, right? I'm going to give you a statement. You're going to have to look in your book of truth and tell me, well, why is that true? So I would say of the four that are showed right there, that is the most challenging one. That I have shown right there, of the four statements that I have right there, showed, right? That's the one that's going to be the most challenging one. So how do you prepare for yourself for that? One, you become familiar with your book of knowledge. You know, if you do this every single time for every single chapter, you don't have to always review back. We're going to be using most of this stuff frequently. Not all of it, but the important one we'll be using frequently. So you need to be able to, I don't know, quickly be able to, what we're saying, 6 pages? Chandler, how many pages in your book of truth? I can't imagine it being more than 6. He says 2. I think if I had done it, mine would probably be 2 as well, too. About 2 pages of things to flip through. You got definitions, you got postulates, you got theorems. That's it, right? Become familiar with it. I will literally, I believe the question literally states in your book of knowledge or book of truth, state the reason. So it's nothing that you have to pull out of thin air. It's in that book. Also, don't just take a guess. I mean, this question, I want to say there's only one question on the test like that. Spend some time thinking about it just to make sure it matches perfectly. Questions? Yes. We'll get to that here in a second. All right. Let's talk about the theorems that we will be using from this chapter. Now remember, I still have this under skills. We're not proving anything yet. We're just talking about the skills. We had some I'm not going to go over every single theorem, just the most important ones. The first one is the midpoint theorem. What's the midpoint theorem? Without looking at your book of truth, what's the midpoint theorem say? Clearly, you must have you got to have a midpoint. So in order to have a midpoint, you must have can't have a line. There's no midpoint of a line. You got to have a line segment, right? Midpoint theorem only applies to segments. So that means you have a segment, we'll just call it AB, What's the midpoint theorem say?
8.5.
In your own words, Wes, what's the midpoint theorem say?
The point between A and B is the mixing point.
Okay, so what do you want to call it?
C.
We want to call it C. And what do we know about point C?
It's equal. The distance from A to B is the same.
One more time and think about it this time.
From A to C, B is. If you were to go to A to C and B, C to B, it would be the same distance.
Yeah? What else does the midpoint say? So Wes said this. He said that you get that those two segments are now congruent to each other, right? It also says one other thing. Not more importantly, it's the same as importance. It says one more thing. It says the midpoint theorem says it breaks the entire segment into two congruent segments, and it says one more thing, which is more of a skill thing. That's great. That's kind of more of a proof statement than it is a skill. What's the skill you get from this one theorem? What? The second part. Say it again. The first part was literally what he just said. You said that AC equals CB. That's what Wes said. The second part was more important. Okay, so we get that, and you could choose either one. So we get that AC is equal to 1/2 of the whole thing. So AB. That's the second part. So those two statements we get from the midpoint. Okay, one, that these two are the same value, and that either one is half of the larger. Okay, what's the test question going to look like? So these are the two skills. What's the test question going to look like? Somebody make one up. And no, it's not going to be that this is 3. How long is the longer piece? What's the test question going to look like? Oh, by the way, what would be the longer piece if that's 3? Okay, that would be what we would do in pre-algebra. What do we do in geometry? You did a bunch of questions like this. What's it going to look like? Did they look like that when I said this was 3? How much is the larger piece? What did your questions look like? Your questions look like this is x minus 4 is that piece, and the larger piece was equal to what? I don't know, maybe it was equal to 4x. Therefore, how big is the smaller piece? That's what a geometry question looks like. Could you solve this now from the given information? So what's the equation I'm going to write? What am I going to write? Somebody. This is where I get the, I'm worried about this class, because tell me what I should write.
X minus 4 equals half of x.
Okay, 2 ways you could do that, right? If you like fractions, exactly what he said. You could extend this and say, what other? There's nothing wrong with what he said. What? Okay, I like that, both of you. Yeah, I'm never going to deal with fractions if I don't have to. It's a midpoint. If this side is x minus 4, the other side's got to be x minus 4. So that plus x minus 4 has to equal
2x.
Not equal 4x. Why do I know that? The whole darn thing is 4x. Ugly, but we could do this, right? What are we going to do? I got to apologize and make this a positive. Sorry. We don't want to get a negative answer. What are we going to do? So we get what? 2x plus 8, and that equals, therefore x equals, who can do that in their head real quick? X equals 4, is that right? Yeah. We would have got a negative answer if I left it as a. Okay, so what was the original question? What was the original question?
How big is AB?
How big is AB? So how big is AB?
16.
16. There's a geometry question. Okay. Are you giving away easy points if you can't do that? Is this hard algebra? No, this is ridiculously easy algebra. This is a ridiculously easy concept of midpoint, right? It's a point, it's in the middle. But if you can't do what I just did right there, it looks complicated. I mean, I'm not going to show that even to an Algebra 1 student. Although an Algebra 1 student could do this. This is a geometry question. Yes or no? Would it have worked using either one of those, their formulas? Would it have been quicker? It might be. Let's see. What did you say? You said x plus 4 is equal to half of 1/2 times 4x. Cadence said she wants to write it an easier way, 4x over 2. Right? All right, Cadence, what do you do? How do you solve yours? She's going to clear the fraction immediately. You remember doing that last year, clear the fraction? She doesn't want to deal with half, so she's going to multiply both sides by 2. Well, the 2's cancel. On this side, you get 2x plus 8, and that equals 4x, and then it's solved exactly, solved exactly the same way. How would you mathematically do yours? Would you have taken a half of 4 and write 2x? Yeah, I'd do that too. So his way, right here, he's just going to take half of 4x, so he gets x plus 4 is equal to 2x, solve that. That ain't bad. You're scaring me. Do we want to do another example of this, or we think we got this? And this is where I won't be scared if you're like, well, we don't like to talk in this class, and this was an easy concept. But I don't even know if that's true because you guys aren't talking to me. Madison, are you confident or not confident on this question? Confident you're going to make a mistake, or you're confident? Okay, remember I said this a couple times in class. I said, I just want you to get you to the point where you're confident that you're going to make a mistake, right? Confident in making a mistake doesn't mean you're clueless. I guess if we put an order of worst to best, it would be clueless, confident that you're going to make a mistake, confident, right? So confident you're making a mistake, which is, so there's just too much algebra there. I know I screw it up all the time, but I know what to do. In my mind, that's where I want to get my students at least. That's like the minimum, right? I want to get you to the point where you're like, okay, I know what to do, but boy, look at all that algebra up there on the board. I'm sure I'll make a mistake. All right, you guys said you're confident, or Madison did. Okay, I could be reading you wrong as well too. The next one was angle bisector. Hey, fundamentally, what's the only difference between angle bisector and midpoint? Fundamentally.
Angle bisector is easier.
It's the same. There's no difference. But fundamentally, the only difference is one is dealing with segments and one is dealing with angles. The definition of an angle bisector is a bisector that cuts the angle. What? What's the definition of a midpoint? A point that cuts a segment. There's no difference. It's the same math, like the same algebra. Great. I'm just dealing with two angles. And yes, the answer is in degrees, not in centimeters. So there's that difference. But I mean, like mathematically, if you can do a midpoint, you can do an angle bisector just as easy. Okay? Questions on either midpoint or angle bisector? Okay. There was only one other thing we did in this chapter, which was what? For skills that we got theorems from. What was the other theorems? We had a bunch of them. They dealt with. Somebody? It was on the homework. Perpendicular lines, right? We got, I don't know, 3 theorems from that. So you tell me, what's the skill that you get from perpendicular lines? It's a small one. What's the one skill you get from perpendicular lines? Skill meaning, what do you got to know?
You gotta be able to identify a right angle.
You got to be able to identify a right angle. That's it. Can you identify a right angle? Okay. Now be careful. When we say identify, it doesn't literally mean the picture necessarily of that. It could be this. What's that telling me? Tell me that. It's telling me that all 4 angles are 90 degrees. So I got two segments, they intersect each other. Where they intersect each other, I get 4 right angles. So when I say, what's the skill? And Wes said, well, you get a right angle. Yes, that is literally the skill. Can you identify that you got 90 degrees? We did get that one other theorem. I'm not going to cover it in detail, that said that if you have a right angle, right, and you have 2 angles like that, what do you know about these 2 angles right here? That they're complementary. Okay, that was the only other one that was kind of strange, but you should be able to get that from a picture. Doesn't necessarily say that this angle is congruent to that one. It could be if this is an angle bisector, but you do get that this one and this one are complementary. Okay. Hey, that ain't a hard chapter. 3 basic things. That's it. That's the only skills. As soon as we go into the higher level chapters, we may get 10 of these in one chapter. You got 3 of them. 2 of them are exactly the same. Something cuts something in half, right? This is an easy chapter for skills. They do get a bit more challenging. Like, wait a minute, there were some more things that we did in the chapter. Seth, give me one other thing that we did in the chapter.
Oh.
That I haven't covered so far.
Not exactly sure.
Anybody? Give me something. We did.
Vertical angles?
We did. So we did talk about what were called special angles. So let's talk about that. How did you know that I was talking about that next? All right. So tell me all our special angles. So we got vertical angles. Vertical angles are?
Ones that practically.
You get this X, and what do we know about vertical angles? Okay, that's the skill, that if you have an X, you get congruent angles, right? Are all 4 angles congruent?
Yes. Well, not to each other, but
When's the only time that all 4 angles will be congruent to each other? Perpendicular lines. But all other cases, the 2 opposite sides are congruent. Okay, so we got vertical angles. There's a couple more. Special angle. What? What'd you say? Adjacent. All right, good one. Adjacent. What do we know about adjacent angles? What else do we know about? Do we know anything else besides that they're next to each other? Like, are they congruent? When are they congruent? When are adjacent angles congruent to each other? Well, that's once. Is that the only time? Okay, well, that's the same one. Could these angles be congruent to each other? It's not that adjacent angles are always, sometimes, or only infrequently. They can be adjacent to each other and be congruent. They can be adjacent to each other and be not congruent. Right? The only time we get something really, truly something special about adjacent angles are those perpendicular line ones. That's the only time. Right? When they're adjacent to each other and they're congruent and they form 90-degree angles, then we get this one extra thing. Oh, by the way, the lines or segments or rays that form them are perpendicular. But they can be adjacent to each other and congruent. We can't say anything about them. I don't even know if they're acute or obtuse. Okay, 2 more. So we got adjacent, we got vertical, we got 2 more. Something about 2 angles. Complementary, supplementary, and that's what we got. So we got adjacent, complementary, supplementary, and vertical. And I put complementary, supplementary in the same. Can you remember which one is 90 and which one's 180? I generally have one kid in class screw this up every year. Right? Remember how I remember it? C comes before S, 90 comes before 180. It's also in your book of truth. Don't be silly and make a simple mistake. So we had special angles. The chapter had 3 basic concepts. It had 3 basic relationships between angles. Right? You're like, well, wait a minute, what about perpendicular? Well, we'll include them right here. That's the whole chapter. That's the whole chapter. There's not much in this chapter. This chapter was an introductory to proofs chapter, how to do proofs. Therefore, what must also be on every test? All right, there will be one proof. For chapter 2, I always do the same thing. For honor student, I give them a blank sheet of paper and say, do the proof. For at level kids, I will write down every statement. You must write down the reasons. And then chapter 3 onward, then you get the same thing as the honors kid, which is you get a blank proof. I mean, you got to come up with everything. So if you're worried about the proofs, you shouldn't be. So it's not a fill. I don't like the fill in the blank ones, right? I'm going to write down every single statement. I think I have a proof with maybe 8 steps to it. Maybe it's fewer, 7, something like that. You're going to have to come up with the reasons. Is that something you at least know what's expected of you? Right? You know what I need to do. Well, guess what? If it's got 7 statements, guess how many you're going to get right? Guaranteed. If I give you 7 statements, guess how many you're guaranteed to get right? 2. Which 2? You better get the first and the last one. The first one is, and the last one is, okay, well, the last one, it's not, you know where it ends. You're still going to have to come up with that reason. I'll just say this. The proof that I chose for you to prove is so similar to ones that we've done that there shouldn't be anyone in here that can't get every single one of these right. I should see, 21 A's on this test on the proof part because you've seen it before. Nothing should surprise you on this proof. In fact, you should wonder, why didn't he give us a more challenging one? That's the test. That's the test. All right. As always in all my class, I don't like to leave it like this. Like, hey, good luck, study. Do it on your own. Which is I give you a little bit of guidance and I give you answers. So I'm not going to claim that this chapter 10, this is your homework, by the way. I'm not going to claim that this is, wow, if you can do this, you're guaranteed to get an A. But I will say this. If you can do this, here are the answers, by the way. If you can do this, get most of these right, you should pass the test. The only issue with geometry is I can't literally do like I do in Algebra 1, which is give you the exact problem and just change the numbers around and see if you can do the procedures. Because these are all, geometry is logic-based, so I can't write the same logic problem differently. Hopefully that makes sense. I didn't realize your hair is so long. Holy cow. We're going to do a geometry problem on your hair. Like when you have it up, like the volume. That's a good calculus problem too. All right. So there's only 12 problems here. I mean, there's a couple of A and B answers, so it's a bit more. But the last proof, notice it says, show me. Give it a shot. Right? I didn't want to guide you through anything. Just here's a blank proof. See if you get started on it. I do believe, let's see, what page is this? 68, 69. I don't think that it's a fill in the blank proof. It is not. 12 is a straight up, hey, here it is. See if you can come up with it.
So do you do this and the
What? Day after tomorrow.
Oh, that's fine.
So the algebra review is, it's a regular class. So we'll do that. Oh, this algebra review is the tough one. System of equations. All right. Hey, I noticed no difference, although Wes tried a little bit. Like I saw no difference in like participation. Right? We're gonna find out tomorrow when I give the test and I get straight A's, and then I will shut up. But if we get like C's and D's, then we're gonna make this a larger point of forcing you to participate a bit more. I would love to teach a class where no one participates because it's easy for me. All I gotta do is lecture. But man, I just feel for you if you're sitting there and you're like, I don't get what he's saying. And I don't want to raise my hand or ask any questions because I don't even know what to ask. I'm that confused. That's what my fear is.
That was me.
No one is turning in homework that's that far off type thing. So maybe I'm the one that's worrying over nothing. But I do know that you guys are very unanimated, which was not the case 2 years ago when I had all of you, except for the new kids.
Steve, you weren't all.
Please.
Not lying.
If we have a 2-hour delay, I don't know if we'll take the test or not. I know it's a 17 or 20 question test, so I need it to be, at least 40 minutes. And snow days are not 40 minutes, or 2-hour delays are not 40-minute classes. So we'll see.
Snow there.
All right, bye now. See you tomorrow. Well, I'm betting that it's going to snow a lot and none of it's going to stick. Yeah, let me have your homework, please. Homework. Nice. Whale. Yeah, but it's colored. That's impressive. Yeah. Thank you. Thank you, Taylor. Thank you.
No. I just got it up to 17.
All right, e-learners, same with you. If you have any questions, none of you have sent me any emails about anything. But if you have any questions, Isaiah, thank you for showing up today. And I will see you guys tomorrow. The test will be posted for the e-learners. I'll have it posted by probably, I can have it posted by noon tomorrow. I'll make a special posting for it. So the test will be posted. It'll be under the assignments tab on Microsoft Teams. So I'll catch you guys tomorrow.